Today's lesson is lesson 8. We're going to start today lesson 8 and lesson 9 to talk about statistical process control. And it's a really powerful tool to help managers have a quantitative understanding about where things are with regard to the manufacturing or service process. In lesson 8, we're going to look at statistical process control for attributes. And attributes are akin, if you will, to a discrete probability distribution. We're going to be looking at things that are countable. And we're going to look at two different types of control charts. We're going to look at what's called a P chart and also a C chart. And the P chart is related to calculating proportions, and the C chart is, if you will, counting characteristics. So that's what we're going to do today in today's lesson. In lesson 9, we're going to look at statistical process control for variables. And variables are more closely related, if you will, to continuous random variables. And we're going to look at 3 different charts, control charts: an X-bar chart in the case where the standard deviation is known, and an X-bar chart in the case where the standard deviation is unknown. And then finally, we're going to look at a R chart or a range chart. And that's going to be today, that'll be in the next class. Statistical process control for our purposes is going to be based on the normal distribution. And again, this is the norm representation, a representation of a normal distribution with a mean and then a standard deviation. And we're going to use that to help us build or construct control charts. And that's what we're going to do for the entirety of the next 2 lessons. We're going to build control charts over and over and over again. Finish writing control chart. And we're going to do this in the following way. So, with respect to the normal distribution, anything between 3 standard deviations above the mean, which is plus 3 sigma or plus 3 standard deviations, or 3 standard deviations below the mean, which is minus 3 sigma, accounts for 99% of 99.74% of the distribution of the variation for a production process. And our process for standard deviation for constructing the control chart is as follows. Along the way, we're going to perform these 7 steps. First, we're going to take a random sample from whatever the operating process is. And it can be one observation or multiple observations, where we're going to take a sample, and this could be either a manufacturing or a service process. And then based on the sample values, we're going to compute for the value of the center line. And almost always, this is the average of the sample that we've collected. Then next, we're going to compute values that are called the upper control limit, or UCL, and the lower control limit, which is called the LCL. And you almost always, these are are calculated by determining this center line, which is the average of the sample, and then the upper control limit is plus 3 standard deviation above the mean, and the lower control limit is minus 3 standard deviations below that mean. And then we're going to create the control chart. We're going to plot on a chart these values of the center line, upper and lower control limits, and also the sample values are plotted on the control chart. And then we're going to examine the control chart just by our eye and determine whether or not the process is in control or not in control, and we'll talk about that more. And then lastly, if the process is not in control, we want to identify the special cause variation. And I'm going to talk in a minute about the special cause variation. And then if once we identify the reason for special cause variation, then we're going to take the steps necessary to eliminate special cause variation. And a statistical control chart is a graph to monitor the production process. And by monitoring the process with the control chart, a person can detect problems quickly and prevent poor quality items from proceeding through the remainder of the process and ending up as a defective product that must be thrown away or recalled. All right, so let's look at this again. Here's our normal distribution, and what we're going to do, to build our control chart. Again, we're going to consider that the mean is here in the center of our distribution, and this is going to correspond to our center line. And then we're going to look for the upper control limit. It's going to correspond to 3 standard deviations above the mean. And then we're here at the lower control limit at 3 standard deviations below the mean. These are going to become our guidelines that help us build our control chart. And then from there, we're going to take this normal distribution, and if you will, we're going to rotate it. We're going to rotate it 90 degrees counterclockwise. And that's what we'll see on the next slide. And here's our rotated distribution. And we're going to calculate, once we calculate the upper control limit, the average, and the lower control limit, we're going to plot those lines on the graph horizontally. And then each observation that we're going to plot, this number 1 is going to correspond to the first sample value. Number 2 is going to be the plot of the second sample value on this scale. And here is an example plot of the samples that we may have taken. And again, there's things that you want to look for as you see a plot of this of a control chart. Number 1, there are no sample points outside the control limits, and in this case, that condition is met. So there's no points outside the control limits. Number 2, most of the samples are near the process average or near the center line. And in that case, of course, that's met here. And number 3, approximately, not exactly, but approximately the same number of sample points are above and below the center line. And you'll see here's 1, 2, 3, 4, 5 plots, 5 points above, and 1, 2, 3, 4, 5 below. So that is met exactly. And then finally, number 4, the points appear to be randomly distributed around the center line. In other words, there's no pattern. So what we don't want to see is the following. What does it mean when we're looking, saying that there's a pattern? Well, a pattern could be, do the points start here and do they increase over time with each sample? Or do they decrease? Or is there some pattern where some are above and then all of a sudden some drop below? Another kind of a pattern would be, suppose there were a regular, and this one almost looks like there may be a regular, but a sine wave in particularly. And then of course, we don't want the case where we have some plots below or points below or some points above. And in any point, the plot that plots out, this would be a case where that the process is not in control. And we'll look more at that as we go forward. So now what we want to do is look at some examples of a P chart and a C chart. And again, these are attribute all attribute control charts. And a quality product or a service can be evaluated using an attribute of the product or a service. An attribute is a product characteristic such as color, texture, cleanliness, or taste or smell. These are things that are countable or evaluated on a yes/no basis. Does the product meet the standard or does it not? So any type of countable or discrete, if you will, measure of quality. And so now let's leave this and let's go to our Excel examples of P chart and C chart.